Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 414, maximum number of moves to kill all pawns. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. This one, I think there is a lot of reading here, a lot of interpretation. I think that's the first tricky part about this problem, and there are a couple of tricky parts. The first is noticing that, right? The first is noticing that, essentially, a possible series of moves is actually a Hamiltonian path of all the nodes, right? Starting from the knight. So basically, you're starting at the knight, and then you're finding a Hamiltonian path, right? Let me put it down here as like some of the nodes or something. Hang on. So yeah, Ham path, right? Hamiltonian path, right? Maybe this is a little bit wrong, actually. Actually, is that wrong? Okay, yeah. Basically, yeah, you're trying to find a Hamiltonian path in this weird game theory kind of way, which we'll go over in a second. But basically, yeah. And the reason why that is because you're trying to visit each node once in the minimum number, a shortest path kind of way, and you can only go to each node once, right? The Hamiltonian path, there's a lot of literature on this, so definitely, do some searching and learning there. I'm not gonna go over that and it's not. Hamiltonian path by itself is actually usually unweighted, so it's not quite a Hamiltonian path, but Hamiltonian path will give you some idea about like the problem. And the key thing to take away from that after you learn it a little bit better is that Hamiltonian path and it's similar but not quite problem of traveling salesperson problem, right? TSP is also they're both NP hard, right? Pretty hard. In fact, it's NP hard, right? So that what that means is that there is no in general there are no no easy way to calculate it, basically, right? They're pretty hard. So the next things from that, once you kind of understand what this problem reduces to a little bit, it's not quite that because the function for cost is a little bit awkward. We can talk about some things in a little bit, but that's basically the idea. Okay, so then now the next thing to notice is that n is equal to 15, which kind of confirms that a little bit. And because when n is equal to 15, that means that, well, it makes certain things possible. And one of the certain things that are possible is that it makes n times 2 to the n algorithms possible. And anytime you have 2 to the n, you probably think to yourself, okay, can I do a Bitmask type thing of it, right? So it turns out that to solve this problem, it is going to be Bitmask dynamic programming. I'm not gonna lie, I think this is I said the same thing last week or maybe the week before with Bitmask dynamic programming, is that I'm not going to go over Bitmask dynamic programming in details for this problem. It is a prerequisite for this problem. And there are honestly much easier Bitmask dynamic programming problems on Leetcode. Come to the Discord and ask people for a couple, and I'm sure you'll find them, or you just search or something like this. But either way, I'm not gonna go over it in that much detail because this is a prerequisite, and that could take an entire day of videos if I just talk about Bitmask dynamic programming. But even beyond that, the last time I talked about Bitmask dynamic programming, people were complaining that they didn't understand it. I'm like, if you understand Bitmask dynamic programming, you would understand it. So I don't want to dismiss it, but sometimes some problems is not, you're just not ready to solve, and if you don't meet the prerequisite, then you're just not ready to solve, and that's okay. Maybe pause this video. You don't have to solve this problem or even understand this problem right now. You can come back to it later, but solve other Bitmask dynamic programming videos, watch problems and watch other Bitmask dynamic programming videos first. But okay, it's going to be Bitmask dynamic programming. And with that in mind, I mean, I am going to talk a little bit about Bitmask dynamic programming, but just not in super high detail that, you know, if you feel like you don't understand what I'm about to say next, then that's probably why, and you know, you can do whatever it is. I know that's a lot of disclaimer, but people keep on being like, you have to, I don't know. It is what it is. You don't, if you don't have the prerequisite, you have to study a little bit before you can, you know, keep going. Okay, so actually, given that, then there is only the game theory part, right? So the game theory part is kind of a little tricky, and I kind of spent a couple of minutes thinking about it, which is that Alice is trying to maximize the score, where Bob is trying to minimize them. And in a way, this is minimax, but I think with minimax, the common thing is that the common thing is that the game is symmetric. And what I mean by the game is symmetric is that usually Alice has the same number of the possible moves as Bob, and also they have the same scoring function, right? They both have the same kind of, yeah, like what if given the same board and it's Alice's turn, Alice wants to do the same thing as Bob. So that's a symmetric game. There are other parts that makes a symmetric game. So if you're the pedantic type, I know, but I'm not going over all of them. But that's an example of one, right? Or at least some of the criteria. But that said, this problem it is not, right? Alice is trying to maximize the sum of moves, where Bob is trying to minimize the moves, right? And yeah, but that part is actually not that bad. It is just that I think it's just a problem that people are not given that much. I was actually trying to reduce this a little bit. The thing is that you still kind of need to prove this, because it's very easy to write your dynamic programming in an incorrect way, such that you accidentally minimize not the state, but a transition of the state. And there's a little bit nuance, or a lot of nuance about that, depending on how you define it. So for me, that was the tricky part. And I honestly, but when I submitted this, I wasn't 100% sure. Yeah. But basically, this is all you need, right? I mean, there is actually another part that you need. I kind of this is the hard part of maybe what you need. The easier part of what you need, honestly, I think, if you're working up to this problem, hopefully you should already know it, which is just shortest path, right? You have a knight. Everything moves in a knight moves kind of way. So this is the shortest path going knight's move, right? Hopefully, I don't have to go into that. I'm not going to go, well, yeah, and hopefully, but also I'm just not going to go into that much detail, because excuse me, I'm not going to go into that much detail because yeah, I mean, this is the shortest path problem for that part, with the knight's move. So let me write that down on the notes. Shortest path with knight's move. Pretty sure this is a Leetcode problem, or 5. So definitely, like I said, I'm not gonna go over this. Assume that you can store that down, and we'll go over it in code, but I'm not going to go over the algorithm part of it, right? It's just shortest path. Keeping in mind that there are only 15 places, so it makes it a little bit easier. And also the entire board is only 50 by 50, which also makes it, easier to calculate, right? Yeah. And with that, that is basically all I need to kind of go about. Oh, game theory, right? Which we'll go over in a sec. So, okay, let's go over the code. Actually, I don't end up using lookup, so we can just remove this. Yeah. So this is the border. I don't know. I just have it here for 50. And as you go to length of the positions, infinity is just some big number. This may not make sense for now, but it is for the Bitmask dynamic programming, which we'll go over in a second. Yeah. So then here we have the first Go function that I'm a little bit lazy about naming. Basically, this is for SXSY, calculate the shortest path to all n positions. yeah, the shortest, well, technically the length of the shortest path or and positions, right? And that's basically what I do here, right? This is using BFS, and yeah, and like I said, everyone should be familiar with this part of it, hopefully. If you're watching a video on Q4 on a hard problem, you really should, that is a prerequisite as well. So yeah, so this part is BFS, right? Yeah, I even defined it for the entire 50 by 50. But for search, start with SXSY, directions, and then we just fill out the BFS, make sure that is inside, and then yeah, and then for each position, we just calculate, we just populate the distance that we care about, right? Okay, and then yeah, and then for each of the I just kind of have an n by n matrix of everything. Okay, and I also do it one more time for the nights. So I have KD for night's distance or something. I don't know. It's a very lazy thing. But starting from KX, KY, right? So then now, so the first move is Alice's turn, right? So then that's why I have this thing on the top, on the bottom. First move is Alice's turn. And it really is simple, which is that for each I, we go, okay, Alice makes the move from the knight to the I place, right? And that's basically what the state represents. And then now it is Bob's turn. So that's why I have a go Bob. So the key thing about this asymmetric game is that, or they have a different function, scoring function, is just have two different functions, one for Alice and one for Bob. And if you heard this for the first time now, and you have everything that you need to know before that, like with the dynamic programming and so forth, pause and see if you could solve it that way. Otherwise, yeah, the first turn move is Alice's turn. So then we go to go Bob. We have I, and we have this thing that looks funky. And basically, yeah, let's go in Bob's function, which is that, okay, what is Bob's function? So, yeah, so it is Bob's turn. We are currently at index, or pawn index, which is PXPY or something like that, right? Or whatever. I already talked about how we already calculate these. So then now we can get rid of it, or just have this distance thing. But yeah, so Bitmask, right? The mask it's just a binary way of representing a list of Boolean values, right? Because basically a mask could be like ones, just ones and zeros, right? And for ones and zeros, then now you can convert the ones to true, false for the zeros, and so forth, right? And that's really basically all it does. And the reason why this is a binary number for Bitmask is that it is just easier to store down. That's basically the only reason. But otherwise, it is just all this. And you have like funky bitwise operation that just checks whether the first bit or the ith bit is true or false and setting them and so forth. Not going to go over in that much more detail, but that's basically the idea. And for this Bitmask, we have n possible n things in the array, if you will, in the list. So this is 2 to the n, right? Because each one could be true, false. So you have 2 times 2 times 2 times 2, 2 to the n. Okay. And then for each one, we just basically say, yeah, okay, so n things in the list, 2 to the n. But in English, it means that it's a list of pawns that are already taken and that we cannot visit, right? It's basically the English version of it. And then now, yeah, it's just brute force in this way, which is that it is Bob's turn. Set best is equal to infinity, then we try to go to, oh yeah, and this is the mask user total. So the total is actually this thing, which is 2 to the n minus 1. But another way of thinking about this is that it just means that all the numbers are done. It's just all ones, right? If it's all ones, that means that all the pawns are killed or whatever, and we visited all the pawns, so then we're done. So that's why we have a return 0 as the base case. Otherwise we just try each pawn one by one. If we haven't visited yet, that's what this if statement is for. We haven't visited yet, then we visit it with this distant thing. But then we go to Alice's turn next, right? We'll go with Alice's function. But yeah, and then now we're trying to minimize the score, which is what I mean by a different scoring function. We're trying to minimize for Bob, so the number of moves. So yeah, so we just get the minimum and we return. And then the Alice part, now the first move is Alice's, but it goes to Bob. And then after Bob's go, it is Alice's turn, so you have an Alice's move. And it is the same idea, really. And we could basically copy and paste. And everything is mostly the same, except for that now here, line 78 and line 95 is different. Because now, and also the best is different because we're trying to max it. It is that here, the difference is that we are trying to maximize the number of moves. So yeah, so we try every move or every pawn. We go to that distance. We go to Bob, and because after that it is Bob's turn with this this thing set with the current index, and yeah, and if the score is better, then we return the best score, and that's pretty much it, right? So what's the complexity for this one? Well, let's go over it in a lot of cases, right? Yeah, so this is going to be n times this cost of breadth first search. This breadth first search costs 50 by 50, mx times mx. So this is actually going to be O of n times mx times mx for this part, and I guess one more. But yeah, but this is for this part, right? But for here, well, there are two dynamic programming things. Each of them has index is going to be 0 to n. Mask is going to be 0 to 2 to the n, right? So the number of inputs is equal to n times 2 to the n. Maybe I lied about it. No, but excuse me. Each input takes O of n time. So total time is going to be n squared times 2 to the n. A classic Bitmask dynamic programming time in general. And yeah, and we have two of these because we have one for Alice and one for Bob. And of course, you can combine them in a funky way because it's only the scoring function. But I think in general, if you separate it out, then you can kind of see how the thing changes. I'm not going to do the same. Bob is the same, right? And yeah, so basically now that's basically the idea, right? So this is the thing. So you have kind of this, which I think in general gets dominated, but yeah. So then this is your total time, and the total space is just n squared times 2 to the n times or plus n squared for the distance matrix thing that I have here. Also, I guess plus mx squared just from each of these from here, and yeah. And that's pretty much it. I'm going to shrink this a little bit so you can kind of see the code. Yeah. This is the top part. Oh yeah, I set the directions up so to be dx dy. So these are just all the knight's moves. I'm not gonna go in here. I must have gone over in other videos, but yeah, this makes it a little bit easier to kind of do this dx dy thing. But yeah, but this is the breadth first search. This caches the n squared distances. This gets the knight distances, and yeah, and this is the Alice function. This is the Bob function, and at the end you have Alice's turns first, and yeah, that's all I have for this one. Let me know what you think. Thanks for watching, and you can watch me solve it live during the contest now. 716. All right, let's go. YOLO. Yeah, I guess I did them in the wrong order, but okay. That's a hard proof though, the greedy, but maybe not. Maybe there's an exchange thing. How am I doing? 16 minutes. It's not updated, so I don't know how I'm doing. We'll see. It doesn't matter. All right, focus. 3 people got this already. Presumably smart people. Alex, good job. I got to focus, Larry. Respect to Alex, but forget about him for a second. All right. What am I? All right. Read the problem first instead of looking at the constraints. Okay, 50 by 50 chessboard. Always 50 with 1 knight and some pawns on it. Okay, so you have the knights and pawns. Okay, turn-based game. Alex goes first. Bob goes second. I guess. Why am I saying that? Okay. And captures it with the knight with the fewest possible moves. So n square maybe to calculate 50 by 50 by 50 by 50. Okay. Okay. Only the set, and then now does the knight change the price? Okay, I mean this is fine. Okay. What is all this animation? This animation is confusing. Okay. I wish there's like they should just show 3 images because this is even more confusing than because I have to wait for it. Okay. Oh, okay. So it does move, but it's there are only 15 of these, so I think that's what they want you to do. Okay. I mean, I have ideas. People are so fast though. 3 minutes is ridiculous. Good job. I'm surprised Alex hasn't gotten it yet, but okay. Because then it's Knight's Tour or whatever. Okay. Yeah, I mean, I think this is doable. Okay. 50 by 50 is a little bit yucky though. Can I do this in a little bit better time? We don't need to do 50 by 50, we only have 15, right? So, okay. So, yeah, okay. And it's equal to length of positions, right? So then now, yeah, I want to get, say, something like this. I mean, it's fine. It's a little bit sloppy. Yeah, okay, fine. It's a little bit sloppy, but let's quite be go. Stop confusing yourself. Yeah, okay, fine. Okay, right, and then this will give you distances. Yeah. What am I doing? What am I doing? What am I doing? This is easy, Larry. This is the easy part. What are you doing? This is the easy part. The hard part will come. Focus. Whatever. Whatever. Okay. Focus. Focus. All right. Yeah. Nope. 50, right? Okay. Yeah, whatever. It doesn't matter. It's a regular buffer search. Okay. What is it? There's only 8 moves, right, Larry? I'm talking to myself. This is how you know I've gone nuts. Larry, what are you doing? What are you doing? Right. Alright. So then now, okay. Okay. And then now we can maybe write it like this. KXKY, is it? All right. Lookup is not. I actually don't know if I need that, to be honest. Maybe I probably do. I think. How did I not do? Just use some break. Don't. This is not time to be funky. That's not great. 0 to 0. Okay. Nope, that's not great. Nope, doesn't print anything. Tell me why you can't get the signs right. Tell me why. Okay, I gotta stop doing that. Apparently that's been a little bit of a meme. Okay, 1 1 to 2 2, is that right? I don't know chess enough. I feel like that should be very obvious. So 1 1 2 2, yep, okay, fine. This is wrong though. How can this not throw an error? I guess it's just because it's no, but this is just wrong because of, well, maybe by 50 is fine, but okay. How did I how is this? Yeah, that is actually kind of I mean, I think the numbers happen to be the same, but that is actually pretty bad. Okay, so then now fewest, okay, sum of the moves. Alice is trying to maximize the sum of the moves of both players, and Bob is trying to minimize them. Maximize, minimize. What does that mean? Maximize. Are they doing the same thing? Bob wants to minimize the number of moves. How many people got it so far? 29. Wow, people are smarty pants. I also took a long time on Q3, I think. But okay. What does that mean? So is it a mini max? It probably is, right? Yeah, whatever, we can just have two things. It's fine. 2 to the 15, is that right? What's 2 to the 15 again? We should be fine. 32,000. Why am I worried? Okay. We are at index mask. Okay. I don't know. I mean, this just makes it a little bit easier. I think that's all. Maximum total number of moves. Okay. So basically, Alice wants to maximize. I feel like I'm a little bit rusty on this. That's why. But yeah. Okay. So well, if mask is equal to yeah, okay, whatever. That variable name is terrible, but okay. So then now, Alice goes to first move. So I think I'm okay. And then now, okay, should be the same. So Alice now goes. How many did Alex solved it yet? Okay, so then now best is equal to 0, or maybe even negative infinity, right? Well, I don't like to use max. Okay, score is equal to go Bob. Okay, yeah, so if mask okay, then as goes Bob, we're currently and then now at I, and then we have a mask. Right, so this is the score if you go Bob plus plus the moves from index to I. Where do I have that? Distances from index to I, right? Okay, and then we have a go Bob. I guess it's mostly the same. Maybe I didn't need to write our thing. Yeah, maybe it's a little bit easier though. I mean, it's the same thing. Nope, not yet. Yeah, okay, I think that's right. And then now we start off by KT is what I called it. Oof, this is not mask, of course. This is inside, right? Okay, 483, 483. Let's hope this is correct. Wouldn't be surprised either way. Kind of type this really fast. Hopefully it doesn't time out. Have ChatGPT ready for timing out. Oh, okay. I already had it ready to convert code, honestly, but yeah, not that bad. Pretty okay. Yeah. Ooh. Uh, no, I mean it's a friendly rivalry. I wasn't like beat me by 30 seconds, Chi Chi. No. Congrats, Chi Chi, for doing well. This one was pretty okay. I thought that there may be something. Um, I thought there may be some way of writing this in a more clever way, but I mean I wasn't that fast anyway. I think I was a little bit confused, and there were some. I was taking a little bit deliberately slowly, just because there are so many possible things to make a silly mistake on. So yeah, I mean the code is similar enough that you could probably rewrite this in one thing, but I think I'm happy with what I did, even though the way I did made like 10 seconds. That's actually a little bit scary, honestly. Can I do a little bit better? I mean let's see if I can upsolve. I don't even know if I would consider it an upsolve, but let's say if I can do it slightly better. I don't know what happened to Alex though. No, don't want to be a stalker, but he was way high up there, super fast as usual. I mean, I think my Q3 kind of killed my time. I was just so slow on it because I don't know. I think it's one of those provy problems. So yeah, but can I write this a little bit cleaner? Is it here? No, I mean this is maybe can I clean this up a little bit? Do I have to fill the entire graph? No, it's only 15 times 2500, so that should be fast enough. This isn't that slow either. In theory. Is it this lookup? I don't know. Let me see. Seeing if ChatGPT could do the manual thing for me. Just put in a lookup table. Well, it turns out I don't need this, so I could definitely get rid of this. But night smooth. I mean, in theory, I could compress this into a thing. No, 25. I don't know if that would actually help me save that much time, honestly. We can write its own memo. I don't know if that's faster though, honestly. Right, so like, yeah. If and we can actually now don't be lazy. We're gonna do it this way. Might as well just use the just make it into a thing, right? So this is this times the outer loop, which is 1. It's total plus 1, I think. Right. So then now, if it's not none. And usually this is a little bit faster, but we'll see if that actually changes anything. What are you doing, Larry? But I just want to kind of clean this up a little bit, making sure this still works. Okay, because this was cutting it pretty close, honestly. We can also like brute force this, I suppose, or like at least cache that maybe. But yeah, I don't know. We'll see. We definitely have optimizations we can make, and that's what I'm going to try to do to make sure that it doesn't time out, or like, I don't know, because I feel like I feel like Leetcode add random test cases sometimes, and it just kind of, you know, around that borderline, right? All right. Does that look okay? Do I have any extra random code around? No? Okay, let's give it a quick submit. See how if it's faster or not. I mean, okay. Kind of take a look. Yeah, I mean, it's only 0.3 seconds, but it's such a, you know, and every little bit helps. But yeah, maybe we can add, oops. Right, so maybe I can do this, right? This may time out, I don't know, but I can definitely do this here. And then add cache maybe, right? And then now, now I go, where's my code? And now for I image of n. Oh, well, there's this thing. But I guess we can have a different, this is go to, right? So then now we can write a more type of go, sy, right? So then go to sx, sy, distance this is equal to this, and then we, and then yeah, that should be good. What? Nope, because we don't have infinity in the right place. Tell me why, dude. I gotta stop doing that. I'm gonna get like copyrighted at some point. I'm gonna take this out. We're singing an NSYNC song. Wait, is it an NSYNC song or Backstreet Boys? I don't know. Okay, this is slightly faster. I guess I should have just have like a max case, honestly, to kind of for comparison. But it is correct. So let's just give it YOLO submit. I mean, it's gonna be a little bit faster. Is it a lot faster? I don't know. Okay, so a lot of it is just calculating it. That's kind of crappy, but okay. I mean, now I'm kind of satisfied. It's kind of weird that we need to do this, honestly, but it's also fine. Maybe, like maybe we could even pre-calculate everything, but you don't really need to. I think this already basically handles it for us. But I'm curious what happens if we do it in another language. All right, convert this to Java. Getting ChatGPT to do it for me. I'm just wondering about the running time more than anything, honestly. ChatGPT is doing that thing where it scrolls slowly, but let's see. Was it 483? Private long. What is private long? 16 lines. What is? Oh, it ran out of space. Oh, I guess it just didn't finish yet. It was still generating. Okay. Alright, let's not have this. 483. Alright, let's give a quick submit. Okay, so what is that running time? I'm just curious. Actually not that much faster. I mean, we still had to, because we didn't do this optimization here, which is fine. I'm not going to. I was just curious whether, you know, because this would be really sad if this timed out, right? And this is a little bit faster, but maybe I could have done this first. I don't know. Either way, yeah. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, this video, everything in between. Yeah. And this problem, of course. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.